Most vulnerability programs have the same problem. The scanner gives you a massive list of findings. Everything is marked urgent, and now somebody has to figure out what actually needs to be fixed first. A critical vulnerability on an isolated test server is not the same as a high vulnerability on an internet-facing system that handles customer data. But a scanner usually does not understand that context. So in this video, we are going to build a simple AI vulnerability management agent that takes raw findings, adds asset context, checks threat signals, and turns the list into a fixed first remediation plan. Not an offensive hacking tool. A defensive prioritization workflow security teams can actually use. Here is the workflow. We start with a sample vulnerability scan. It has CVEs, severity ratings, CVS, as scores, affected assets, and recommended fixes. Then we add asset inventory. Which systems are production, which ones are internet exposed, which ones hold sensitive data, which ones support critical business processes. Then we add threat context. Is this CV known to be exploited? Is there public exploit activity? Has it been connected to ransomware campaigns? The agent combines all of that into a prioritized remediation report. Instead of saying, here are 400 vulnerabilities, it says, fix these 5 first, here is why, and here is who should own them. Severity is useful, but severity by itself is not risk. CVSS tells you how technically serious a vulnerability can be. It does not always tell you how dangerous it is in your environment. For example, imagine 2 findings. Finding 1 is a critical CVE on a lab machine that is offline, has no sensitive data, and is scheduled to be rebuilt tomorrow. Finding 2 is a high CVE on a public-facing VPN server used by employees every day. If you only sort by severity, the critical finding might appear first, but from a real risk perspective, the VPN issue may deserve immediate attention. That is where an agent helps. It does not just read the vulnerability, it reads the context around the vulnerability. For the demo, we keep everything local and safe. We use 3 simple files. First, a vulnerability file. This is our scanner style output. It includes the CVE title, CVS score, severity, affected asset, and recommended fix. Second, an asset inventory file. This tells us whether an asset is production, internet exposed, business critical, or connected to sensitive data. A third, a threat context file. This is a simplified version of what you might get from sources like CISA KEV vendor advisories or threat intelligence feeds. In a real environment, these could come from tools like Tenable, Qualys, Rapid7, ServiceNow, Jira, or a cloud asset inventory. For this video, synthetic data keeps the demo clear and safe. Now we build the prioritization logic. We start with the CVES score as the baseline, then we add context. If the CVE is known to be exploited, the score goes up. If an exploit is publicly available, the score goes up. If the asset is internet exposed, the score goes up. If the asset is business critical, the score goes up. If the asset handles sensitive data, the score goes up. The point is not to create a perfect mathematical model. The point is to create a repeatable decision system. A good vulnerability management process should be explainable. If someone asks, why are we fixing this first? The agent should be able to show the evidence. The agent layer is where the raw score becomes a useful explanation. The code can calculate risk, but the agent turns that risk into a human, readable summary. It looks at the top findings and explains what matters. For example, this vulnerability should be prioritized because it affects an internet-facing production server, has public exploit activity, and the system supports customer authentication. That is much more useful than a spreadsheet row. This is also where we keep the human in the loop. The agent recommends priorities. It does not blindly patch production systems. A human reviews the report, validates the context, and approves the remediation plan. The final output is a remediation report. At the top, we have an executive summary. How many findings were reviewed? How many are urgent? What is the biggest risk theme? Then we list the top vulnerabilities to fix first. Each item includes the affected asset, CVE risk score, evidence recommended fix, and suggested owner. This matters because vulnerability management is not just finding issues. It is driving them to closure. A report that says patch this CVE is okay. A report that says platform team should patch this internet-facing authentication server this week because exploitation is active is much better. There are a few important guardrails. First, do not let the agent make destructive changes automatically. Start with recommendations, tickets, or draft remediation plans. Second, keep the logic transparent. If the score changes, you should know exactly why. Third, validate the data sources. A bad asset inventory creates bad priorities. Fourth, measure outcomes. Track whether the agent reduces time spent triaging findings and whether the highest risk issues get fixed faster. Agents are powerful, but in security, trust has to be earned through controlled workflows. Once the basic version works, you can expand it. Connect it to real scanner exports. Pull known exploited vulnerability data from CISA KEV. Add asset ownership from your CMDB. Create Jira or ServiceNow tickets for approved fixes. Send a weekly executive summary to leadership. And eventually connect it to a broader security operations pipeline with monitoring, incident response, and compliance reporting. The key is to start narrow, build one workflow that saves real time, then expand from there. That is the core idea behind an AI vulnerability management agent. It does not replace the security team. It helps the team focus on the vulnerabilities that actually matter. In the next video, we are going to move into GRC and look at how AI agents can help with compliance checking, policy review, and audit prep. If you want more practical AI agents for cybersecurity and automation, subscribe to CyberRiderX.